Okay, let's get underway. Rao is attending to some personal matters over the next couple of days. And so today's technical update, if I understand correctly, will be given by Tomislav. Is that correct, Tomislav?
Yes. And also I have a small demo to show.
Fantastic. Wonderful. All right, well, I'll give the floor to you and look forward to the demo.
Hello, everyone. So I have a small demo. I was not sure if I will be able to finish it, but I have something to show. So it's all related to finalization, of course. So first, I want to say something what we are doing right now. So the finalization algorithm is finished and working on the simulator, and now we are preparing the node to integrate the new finalizer, which works with multi-parent justifications. So just to say what is the amount of work that we need to do in the last 3 PRs. We removed a little more than 2,500 lines of code, and but this doesn't mean that we dismantled everything. Most of the tests are passing, and only the code that is related to finalization is ignored for now. So all of this months of preparation enable us to do this kind of big changes, and without changing all parts of the code or changing the functionality everywhere. So who is doing what? Stas, Anton, and I are working on this integration, and Will is more oriented on the rolling stuff related to contracts upgrades and changes to POS, Revolt, and similar things. So we want to ensure that with Hardfork 2, even if we don't have all functionality immediately in the rolling code, we'll be able to update these contracts later when we have the new version. I just want to mention that with all of these changes, we are talking about Hardfork 2 as a major thing, but we are with this release, we are basically including many things that we already have in our roadmap, but after Hardfork 2, which are now which will be released together with the Hardfork 2. So let me now share my screen. So I want to show this is the repository where I was working on the simulator and the finalization implementation. And one of the important things is that we need to visualize the DAG that we are finalizing, because without that, it's very difficult to understand what code is doing, and is it how we can we are progressing in good direction. So I want to show we were talking about the finalization fringes, because with multi-parent finalization, we are not finalizing only one block. We are finalizing the boundary or the layer, and so it's not just easy to imagine what exactly where this boundary is. And you probably seen our visualization with the GraphViz, with which node can generate the source. So so for example, we can have things like that. But what I want to show today is the fringes, and what I did is I made some coloring on the same visualization graph, because the GraphViz support that. So you can see here in this very simple or very simple DAG, in a sense that all validators producing blocks at the same time. So we see here that each color represents a different finalization fringe. So if we are starting from the genesis as the first finalized block, which doesn't have to be, we are looking to simplify the genesis ceremony where we can apply the same logic for even from the genesis block. So here genesis is finalized, and then each layer, and this is what we are calling the fringe, is finalized how when the new blocks are built on top. So the last three layers cannot be finalized yet because they don't have enough stake. But you can see here how. So what I didn't able to finish today is to mark which block finalizes which fringe. So, for example, the block 04 can finalize the first fringe, this purple one. So I'm planning to include some kind of border of each block in the same color. So when you look at this DAG, you can immediately find out which block is referring to which fringe. So now I want to show little bit more complicated DAGs. So we can see here that even in this DAG, we cannot finalize even the first layer because the network is splitted. So the layer doesn't have enough stake. But now when we have some merging of the branches, now we see the layer finalized. And if we have even more blocks, now we see how the fringe can be even if some node is a little bit late, when this node produces new blocks, this fringe becomes finalized. And maybe some little more complicated DAGs or longer DAGs. You can see here how these fringes are finalized. And they're in the sense they're equalizing, because even if some node is slower, he will have some gaps, but the faster node will have more blocks included in this fringe. So for example, here between this purple and pink, we have this white ones. And this just means that all of these white ones they are included in the next fringe. So this node was a little bit faster, this was slower, and when the next layer was calculated, all of these blocks are finalized together with this pink one. And this is even more a longer DAG. And for example, this is even difficult to recognize what is going on, because this is something that we will have if we detect some strange situation with the DAG. We can generate the specific. So we are generating randomly. We are generating these DAGs, and even if we catch some bug in the future, we can store this randomly generated DAG in that moment, so that we can create the test from this specific DAG and include it in all future code. And even if we later, when we apply the fix, we want to be sure that we don't have some kind of regression bugs, and so we can replay all these specific tests. So this is one of these DAGs that we catch some bugs, and now it's included in the simulator. And you can see here how this DAG is very it's missing lots of blocks. So finalization is very difficult to achieve. So there is lots of blocks created, and there is no too many fringes. So this is probably something that we will not see in the real in the real network, but we can definitely simulate this kind of attacks. And of course, all of this coloring will be we will include in the node code, and so any user can use it to generate and see the tag. And this is all that I wanted to show. I hope it makes sense. Yeah, if there is some question.
Thank you, Tomislav. That was great. Really good. Did you have any other tech updates? Were there any other major efforts or things to report on the whole?
So I wanted to say that I hope that next week we will be able to connect the new finalizer with state merging, so that we can publish the first release on the testnet. So I cannot say that this will be that I'm completely sure, but we are definitely going into that direction that we can do this for the next week.
Very good. Very good. Thank you. I appreciate it. Excellent. Excellent demo. Excellent update. Any questions for Tomislav?
I do have a question. Is there a tool of some kind, or a detector or something, where you're determining that there aren't enough fringes, or is this a visual inspection analysis thing? And in addition to that, would that tool have to run alongside mainnet in order to detect bugs in production?
Protocol, you don't get advancement of finalization if you don't have the fringe. Like the state moves forward as a result of the finalization fringe. So the protocol is detected at itself. There's no exogenous mechanism that we apply it. It's not like there's not enough fringes in order to have the state advance. You have to finalize across all the validators.
Okay, so the algorithm itself detects when there are possible problems and reports them?
Yes. The simple answer is yes.
Yeah, this is.
Go ahead.
Well, I mean, what's running through my head is, no production software is bug free, and so how is it that in a production environment we might detect a bug that needs to be fixed in finalization?
So with the simulator, we want to basically check all the situations that probably we will not see in the real network. So with the simulator, we can run we can create the DAG much faster than in the real network, because we are not replaying the blocks and all the other additional work. And how now the algorithm is implemented. We have few layers that we will have tests for these layers. So the simulator and all of this checking is just additional testing that we want to ensure that even if we generate random DAGs, we will not see any problems. But we will apply the normal testing framework and check these layers of how the algorithm is implemented. And what I showed with the visualization is direct result of the algorithm calculating the finalization fringes.
Okay, I mean that makes sense. Is there going to be a mechanism by which we could take the state of the currently running, like say testnet? So we take the state of the current testnet, run it through the simulator, and do this kind of analysis.
Yeah, of course.
Okay.
And not only that, we can have multiple implementations and run it together. And this is one of the goals for the simulator, that we can compare multiple implementations and see are they agreeing in all the random generated X. So this is additional layer of testing. So not only just that we are checking the code, we want to be completely sure that in any possible case we don't see any problem.
Okay, that answers my question. Thank you.
All right. With that, unless there's anything else, we'll move along. So we had a special board meeting this week. To the best of my knowledge, there were no votes taken. It was largely informational. So nothing to report there. We are ramping up for the engagement with the UK news distributor. So more on that in the closed door session. It's very exciting development for us, and more news on other enterprise contracts coming our way, which we will talk about in the closed door session. This week, I had the good pleasure to chat with Matt West. So Matt West is he lives in Oregon, and he is running for a seat in Congress as a congressional representative on a climate change and pro-blockchain platform. So there was a tremendous meeting of minds. He really was very excited to hear about what Archain is doing. I know personally, I'm very much in favor of having people like Matt West in Congress. I think he put his finger right on it. The existing legislators are just scared of new technology, a lot of them, and so we have to get people in who actually understand the technology, so that we can have decent policy. And it was great. On top of that, Matt is very, very aware of what's happening in terms of climate change, and that we need to we're going to need to roll up our sleeves and work on all fronts. We have to work in the public sector, we have to work with the corporate sector, and we have to work for grassroots self-organization. All of them, we have to be firing on all cylinders, because what's coming is going to be just frankly terrifying. So we are all going to have to pitch in together just to make it through what's coming. And so Matt, I think, also understands that and wants to make sure that there are good people in the public sector to help work on that. So I strongly encourage people to take a look at Matt's platform, and just in general, I can say that I had a front row seat to when I joined Microsoft. Like, I joined right at the time that Microsoft was being hauled in front of Congress, and so I had a front row seat for all of that. And I vowed that if I were ever in a situation where I was heading up a company, I would make sure that we had good relationships on Capitol Hill long before we needed to be. So we would be proactive about getting in front of Congress, and so that our conversations with Matt are a part of that proactive business strategy. And in addition, we have been working with other folks on Capitol Hill who are, the plan is to be able to provide information and education to all of the congressional committees on blockchain, so they can be informed as to what the technology is, what the technology isn't, places where we see applications, and what our aims and goals are for the technology. So this is a part of our explicit business approach, and so chatting with Matt was very much in alignment with that, as is chatting with other resources on Capitol Hill, which are ongoing. In fact, more on that, the closed door session we had. We're getting interest from other sectors in government, the U.S. government. So with that, let me just check and see if there are any questions about that.
I have a question about Matt West. So he's in Oregon, right?
Yes, that's correct.
Was there any kind of talk about Oregon's plans on cryptocurrency regulations and blockchain regulations?
Indeed, yes.
Oh, I'd be super curious to hear about that.
Sure. I strongly recommend that you take a look at his site and
Okay.
and reach out to his campaign. I'm sure they will give you an earful. I wouldn't want to represent Matt's campaign. Let Matt speak for himself here.
Okay. Yeah, I'll check it out.
So Daryl, you ready for the weekend review?
Sure. Okay, so here is the weekend review from Thursday, April 14th to today, April the 20th. In the Climate and Coordination RCast, Michelle Tseng from the Los Angeles Philharmonic joined us. We discussed music as a coordination technology, the psychology of working as a group, and her experience recording with Billie Eilish, amongst many other things. Yesterday in the Communications Working Group, we discussed Steve Henley's Content Calendar Initiative and his work towards improving our Twitter presence. And Anthony proposed that we produce an explainer video of sorts that actually demonstrates how RChain scales as you add hardware. And a small group of us are going to be meeting later today to start working on this. And this morning in the active member hangout, we discussed Elon Musk's Twitter moves, cancel culture, engineered behavior modification, how to use comedians to promote RChain, which somehow led to a conversation about optimizing security on our devices. And as far as Casper stand-ups go, Greg, I haven't received the last two. So maybe you might want to talk to what you spoke about during those Casper stand-ups.
Awesome. Yeah, are you done with your update?
I am done, yes.
Okay, so the last two Casper stand-ups have been focused on one way to put the type system to use that's a little different from the way the types are just sort of natively generated. So we're at the point now where we are clear that the calculation does in fact yield the model that we expected it to, and so now we want to verify that the types have the range of applicability that we want them to have. So the overall sort of burdens of proof in investigations like this is, first you want to say kind of what the types are. So what sort of type system is generated for each model of computation, and then you want to show that the type system that is generated has a semantics that is clear, and that semantics lines up with the syntactic calculations. And then after all of that math is done, and that's a lot of math, let me tell you. After all of that math is done, then you also want to say that, here are some intended applications for the types, and that they do in fact give us good good checks on the kinds of code, smart contracts, for example, that people would be writing. And so we've done a lot of that over the past, just as a kind of motivation. But there is a place where the mobile process calculi, specifically as models of computation, shine over other models of computation. And that has to do with dynamic and reconfigurable communication topology. So in particular, I think we are all very used to, at this point, learning from someone that we know, or maybe someone we just met, contact information from someone that we don't know. So you might learn someone's phone number or their email address or a website that they maintain. And so if you think about the graph of people, and the edges represent communication channels, possible communication channels, right? Then that graph is evolving, it's changing its shape as people learn contact details of other people, and also as people forget contact details of other people, or other people, change their phone numbers or their email addresses or what have you. So the graph itself is not static; it's changing shape over time. Who knows whom? Who can connect to whom? Who can talk to whom? That is changing over time. And it happens in the internet on a regular basis. A customer walks up to a well-known URL like www.amazon.com, and at the point where they actually engage in a sale, right? So they kind of done their searches and they finally select a product. So then at that point, a fresh URL is generated for that session with the customer. And so that's another place where the communication topology is dynamic. And it doesn't stop there. So when molecules out in the chemical soup that is nature, when they bump into each other, they're often bumping into each other for the first time. And when molecules impinge upon organisms, that communication topology is dynamic and reconfigurable. So the reason I'm giving some number of detail about this is for people to recognize that it's ubiquitous, that it happens all the time. It's not something that is a weird or edge case. It is in fact the dominant case for communication topology in both the human world and in the natural world. And surprisingly, or not, depending on your outlook on things, the formalisms for dealing with the dynamic communication topology have only arisen in the last 30 years or so. So the mobile process calculi are, in effect, the only computational models that naturally and easily support this kind of dynamic reconfiguration of the communication topology. This is, in fact, why they're called mobile. they were invented to deal with the mobile connections, sort of cell phones and things like that, but also the other range of phenomena that I've discussed. Now, one of the things that one of the most widely accepted now formalisms for reasoning about a wide range of mathematical and computational frameworks is category theory. And so, for example, when one is giving semantics for types or for other kinds of systems like this, you will and often uses category theory to reason about them. And types figure quite extensively in category theory. But category theory is very, very much organized around static composition. So things are wired together statically, and the formalism is you can see this even in the syntax of the formalism. It doesn't support a good syntax for reconfiguring what's composed with what. And so there's a sense in which the category theoretic framework, even though it's well established and widely used across a lot of domains, it has some great ideas, but it's missing some ideas. And the mobile process calculi have some great ideas, but maybe they're missing some other ideas that they could get from category theory. And so it's a very interesting idea or thought to bring the two worlds together. And so, so over the last, and in fact, this was a thought that that brought me in contact with my PhD advisor, was to look at types, typed-based approaches to the mobile process calculi that would give categories that describe interaction. So my advisor and many of his students wrote several papers on interaction categories, and that, back in the mid to late 90s, that was a hot topic, was interaction categories. It turned out to be a tough problem. It turned out to be very, very difficult to crack that nut. And so one of the tests for the OSLF algorithm is, can we crack that nut very generally across a wide range of models of computation and notions of types? And it turns out we can. So the last two Casper stand-ups, we've sort of focused on the apparatus to describe a class of interaction categories based on the OSLF data that's generated. And then to apply it to reasoning about a very simple, simple system where you have Alice, who is a customer, Bob, who's a broker, and Carol, who is a supplier. And Bob sort of connects Alice to Carol and Carol to Alice. But Alice has been very cagey in the sense that she's only giving Bob a burner phone number, right? So it's a fresh place to contact her, not her well-established email, which she keeps private, or her well-established phone number, which she keeps private. And likewise, Carol is only giving Bob a burner phone number or a fresh email. And what Bob does is he connects Alice to Carol and Carol to Alice, where they're connected via those fresh numbers that they've just spun up for this particular interaction. And then Bob gets out of the way. And so you want to be able to prove that at the end of their interaction, that Carol is connected to Alice and Alice is connected to Carol along these fresh or are private channels that are private just to Alice and Carol and nobody else. And that even though Bob got them connected, that Bob no longer has any visibility into those channels, that Alice in particular, even though Bob got them connected, Bob can't eavesdrop on the Alice and Carol connection. And so you'd like to be able to prove that just from the fact that, the Alice process has a particular arrow type in a particular category, and Bob has a particular arrow type, and Carol has a particular arrow type. And when you glue the arrows together, just following your nose in terms of how the types fit together, that you get this property, and you can show that in fact does happen. So it works very much in the way that category theory expects things to work, and it kind of brings together this very static world of category theory and this very dynamic world of mobile process calculi, and which we can think of as more like how the internet actually works. and at the same time, it makes all that type checking stuff kind of happen in a natural way. So it's not in your face. It's not causing you to have to leave the system and go think about another tool or another formalism. You just kind of write out Alice as a smart contract in Rolang. You write out Bob as a smart contract in Rolang, and you write out Carol as a smart contract in Rolang, and just wiring up the smart contracts in the natural way results in knowing for sure with certainty before you ever run the code that those properties that I mentioned before, that the Alice contract and the Carol contract ultimately establish private connections. And even though Bob is the broker who got them connected, Bob can't eavesdrop on Alice and Carol. So that's what the last two Casper stand-ups are about. Sorry, that was so long-winded. Hopefully that makes some sense. Any questions about that?
Greg, so some years ago, I did some work with wireless mesh networks for digital devices.
Sure.
Sounds like that is a singular use case for the general that you're discussing here. Is that correct?
It's one of them, one of many. You can certainly use it for wireless communications. You can use it for
specifically with the mesh network, right? Autonomous connectivity. And I'm just curious. I mean, this may be too detailed here, but I'm curious. One of the problems that we had to deal with mesh networks was the bow tie problem. I don't know if you're familiar with what I'm saying, but I'm wondering if you found a solution to that.
By that name, I probably know the problem, but I don't know it by that name. So
okay, well, we'll talk another time then.
Mesh networks are definitely an area of application. Wireless communication, internet-based communication, chemistry, biology, a wide range of other things all fall under this purview. But it also allows us to bring together these very different worldviews, right? So the worldview of this dynamic communication topology from the mobile process calculi, that's very well established, right? There's whole computer science departments that are have expertise in this area, and then there's the very static world of category theory, and there are research institutes and whole computer science departments that have expertise in this area. And what we're showing is that the two worlds can share their strengths with each other. And that's a powerful thing. All right. So I think that's about it. Any questions, comments, worries, concerns from the community? All right. I noticed that we have a new face. Reza, are you in a place where you can say hi and introduce yourself?
Yes. Can you hear me?
Yes.
I am Reza Afzalan from Iran.
Nice to meet you. Nice to meet you. What
Yes.
brings you to the ArtChain Cooperative?
Yes, I love ArtChain. I love its Rolang and like to know more about it. I am a member for I think more than 2 months ago.
Awesome.
I I try to follow
Excellent.
and learn as much as possible.
How did you hear about it?
I am in crypto for I think many years, and yes, from listing sites and from your videos, YouTube videos and blog posts. It's normal, yes.
Thank you. Thank you. Wonderful. Well, welcome to the community, and we look
Thanks a
forward
lot.
Yeah, we look forward to your engagement.
Yes.
Awesome. Any other questions, comments, worries, concerns, anything? All right. Well, thanks everyone. Please stay safe. At least in Seattle, it's still quite chilly. So stay warm, and we'll see you on the other side.